Hi there, this is your favorite math learning channel, and in this video I'm going to introduce you a very important theorem, or we will just use the method part. I won't really go into theorem part of it, and it's very useful to find general terms of a sequence of the rational form, like polynomial form, and it can also be used to find sum of first n terms of such type of sequences. So first, let's talk about what's going on here. So we have del, and this is actually working like d at normal analysis. So this is just derivative operator, and this is derivative operator of the discrete calculus. So what this is saying is that so del of a function. So we can either just use an or fx. So this is gonna give us f of x plus 1 minus fx. And at the Stolz-Cesare theorem video, I also explained that where this is coming from, that so when we are taking a derivative of a function, this is normal derivative, so we say limit as increment h goes to 0, so it's f of x plus h minus fx over h. And for sequences, we can't really make the input like with we can just increment the input as much as we would like. So the best we can do is picking the h being equal to 1. And if you do that, we go to this word, and there's just a bunch of really cool stuff there. I will make some videos about it, but yeah, not yet. So this is kind of like the first one. And here also, like, we have this like powers, and what this means is that so if you take like second so like parenthesis power, there are different notations about it. They also make it like this. So this is falling power, and this means that you just take this number and you like go down 2 times. Okay, so basically we are going 1 times, like however you say it. So, and this is actually equal to this part, which is gonna look more like familiar to you. So this is just a binomial expression. And so let's see how this is used. So basically we are going to take differences of the sequence. For example, I have that sequence an, which goes like 0, 3, 10, 21. So it's going like this. I'm not going to write the rest of the terms. We are supposed to find general term of an as an. So we are basically trying to find like this is a function of n, so not just numbers. Okay, so this is like a1, a2, a3, so it's going like this. So basically here, like I said, here we are going to take differences of the terms, and since for this function x, all of these like values, so these are all just constants, so we don't really need to again just put zeros here. We are not going to need that, so we can just take differences. Okay, so if I take this difference, it's 3. If I take this difference, 7, 11. And so this was the first differences. Let's write it. So this was delta an. And if I do it again, let's write delta squared an. So if I take this differences again, it's going to be 4, 4. So it's going like this. And if I take it again, delta cube an. So I'm taking third differences of an. So this is like d cube, like del cube f over del x cube. Anyways, so if I do it again, it's just going to give me zeros, because if you reach the constant row, the next rows, all of the next rows are just going to be 0. So anything below is just going to be 0. So therefore, we can just stop it here. And we can write our general term as with the formula. So what we are doing is that we are just writing the first one, 0. We can also write this as 0. So instead of this x's, I'm going to put n. So n chooses 0 plus. So this first term, 3. So I'm looking at this row. Okay, maybe it's column. So this is 0. This is 3. 3 times n chooses 1. 4 times n chooses 2. And all of the rest terms are just going to be 0 times something, so they're all just going to be 0. And here also a nuance, that this is not going to give you of an, it's going to give you a of n plus 1. So instead of n, you can just indent, you can just put n minus 1. Okay, so here what I can just write it, so it's 3n plus 4 times n minus 1 over 2. So these two will just cancel out, and we can say, so this is just 2n squared plus n. So this is actually true. Let's check some values. If I put n is equal to 1, so this is correct. And so if I put n is equal to 1, it's gonna give me 2 plus 1, which is 3. But if you look here, so this is actually equal to a2, and it indeed the second term is just 3. If I put 3, so if I put 2, it's going to be 10, which is the next term. 3 is going to give me this one. If I put n is equal to 0, it's going to give me the first term. Okay, so this works. You could also, like, instead of n, you could put n minus 1, and you would find that an is just, I'm not going to do the algebra part, it's just 2n squared minus 3n plus 1. So this is how this method works. It works like a charm. But like I said in the beginning, so this thing works only if the answer is in this form, which means that if it looks like kind of like a polynomial. Okay, so you should be careful. And so the second part of the video, so we will learn that how can we use this to find general term of a summation of sequence. And so for that, let's take a like really famous sequence of an is equal to n squared. So we are going to try to find general term of this summation, n squared. So instead of n, let's use another letter. Let's say I goes from 1 to n. So we are trying to find this summation. And to do that, again, we are just writing first terms. So if I put n is equal to 1 here on the sequence, I'm doing it on the sequence. 1, 4, 9, 16, 25. So it's just going like this. So I'm again taking the differences. So this is going to be 3, 5, 7, and I'm writing it like not literally like on this part. Just to make it a bit more clear, I'm just shifting it half. So if I do it again, it's going to be 2, 2, 2s. So I reached the constant row, and so the rest terms are just going to be 0. Also, we can use this method. Let's do something else. Sorry, so this should be 11. And if I actually use this method, I could also find the next term. So if I didn't know what is this thing, I can just, so to reach this, if I add these two, I'm going to get this one. So if I add 25 and 11, it's going to give me 36. And this is indeed the next term. So this is just another extra of this method. And so here, if you look at this part, what we did was, so we said I took the first term and I multiplied it by n chooses 0, then n chooses 1, n chooses 2. Here, what we are going to do is that, so to find sum of n terms, so I imagine this is I again. I goes from 1 to n. So I just added 1 squared plus 2 squared up to n squared. So this is equal to, instead of now starting from 0, I'm starting from 1. So I have 1, this 1, n chooses 1, plus 3, n chooses 2, plus 2 times n chooses 3. And that's it. So this is our answer. Like, look, so if I just expand it, it's going to give me n plus 3 n minus 1 over 2 plus 2 n three times 2. I can just simplify this, and this is my answer. So you can just do the algebra and find that this is equal to, so basically we know that this should be equal to n plus 1, 2n plus 1 over 6. So we know, like, this is a really famous identity. And let's also instead just check few values of it. So I have here, if I put n is equal to, let's say, 2, so this thing will just be 0. If I put 2, this will cancel out. It's going to be 2 plus 3, which is 5. And it indeed, like, if you add the first two terms, it's going to give you 5. If you put n is equal to 3, it's going to give you 14, and it works like a charm. So this is the second way. So like again, if I'm trying to find summation, I start from 1, I start choosing from 1, and I just go up to where it's 0, so all of these terms are just going to be 0. And if I want to find general term of the sequence, I'm just starting from n chooses 0, and this is giving me a of n plus 1. And that's it for this video.